In this video, I want to just talk about the del symbol here and the three different ways that we've used it throughout this course. So this right here, I usually call this del. Also, some older books and some professors, they might call this nabla. This is maybe a little bit more old-fashioned term for this. But you should definitely just be aware that del, nabla, they both mean the symbol right here. And I think that the best way to think about this is that, assuming we're working in 3 dimensions, the del operator, it's a vector that consists of 3 partial derivative operators. And so when we have the gradient, here, well, the gradient was something we learned back in chapter 14 when we were working with functions of 2 or 3 variables. The gradient, we had del applied to f. This was a vector here. So let me just kind of write out del using this notation. Partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z, applied to some function f, function of, let's say, 3 variables here. And so you end up with a vector with the 3 partial derivatives in it. And then curl is something we've just learned about here in chapter 16. We can find the curl of a vector field. And so it's going to be the partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z, cross, m and p here, assuming that our vector field f has these 3 as its entries here. And how do we evaluate it? We evaluate it as a cross product. That's our usual way to do it. And then finally, for divergence here, del dot f. So the dot product notation is suggestive here because this partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z, dotted with, let's say again, that are the component functions of f are m, n, and p here. It's this dot this. And what do you do when you do a dot product? It's this times this plus this times this plus this times this. But we have to be careful. We don't actually mean this times this. It's the partial derivative with respect to x applied to m, which is the partial derivative m with respect to x. Partial derivative y applied to n. And the partial derivative z applied to p. And then because it's a dot product, we add up all of those entries here. So we have these 3 different uses of the del operator. And I'll point out here that when you do the gradient, the output here is a vector. When you do the curl, the output is a vector. When you do the divergence, the output here is a scalar. And that kind of like, because there's a dot product in there, well, we know that dot products give you scalars. And I'll kind of point out also, like if we're thinking of del as a vector here, let me just write vector, vector, vector. And then what is the function we're applying it to? Well, up here, this is a scalar function. This is a vector function. And this is a vector function, a vector field. So a vector times a scalar gives you a vector. That makes sense. A vector times a vector. Well, we have to be careful about what do we mean by a vector times a vector. A vector cross a vector gives you a vector. A vector dot a vector gives you a scalar. So we see here these 3 uses of the del operator.